Hello, this is an overview of my one of my projects that I was working on last week. Essentially, it's a Sudoku algorithmic solver, aside with the basic functions to play Sudoku itself. As you can see, these are the codes, and also the backtracking algorithm. And then once we start running it, since it's using Pygame, it's slightly a little bit slower. But after a few moments, the Pygame window will start to load, and then you will be able to see the grid along with the timer, as well as the empty spots, the current numbers, so on and so forth. Now, you can type in any number you want, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you try to solve the Sudoku using the number keys on your keypad. And if you get one wrong, for example, you put a 9 or a 6 here, and then you press enter, and then it's wrong, so it will give you a big X. And then there's also a timer that records how long you've been spending time on this. And then once you get it right, and then, for example, in this scenario, we place a 5 in that grid, and then we press enter, and then the number will become a bolded number, so to show that it's correct on the grid. So moving on to the backtracking algorithm, the Sudoku solver. So the Sudoku solver uses a sort of backtracking algorithm to improve its effectiveness in comparison to brute forcing. So it uses slightly less time in comparison to brute force. It takes about 10 seconds less to solve the algorithm. And then so as you can see, the timer froze because the programmer is running the solver right now. Once we press space bar, and then we'll start running through the numbers, and then start analyzing the grid, and then after about 10, 15, 20 seconds, and then it solves the entire grid with flawless combination. And of course, you can also customize the grid to whatever Sudoku grid you like. So yeah, it's very effective.